Welcome to this section of our presentation. Today we are glad to be here presenting normally like we do on our YouTube channel, the Dolo YouTube channel. We ask that you kindly subscribe to our YouTube channel, like and share our video. Today we are solving problem on a topic very interesting to help mathematicians out there. Like we always say, our channel, this channel is built to help mathematicians, to help inspire, transform people who are afraid of the world of mathematics. That's why we create a platform of innovation, and people out there will be inspired and they will join the quest of becoming a mathematician, because we believe that numbers is important and mathematician can transform our world. Therefore, to quickly go to our topic, we are on the piecewise-defined function. And piecewise-defined function, this topic has several names. If you like, you can call it piecewise function. You can say that piecewise function, P-I-E-C-E, piecewise function. Hybrid function, H-Y-B-R-I-D, hybrid function. Or you can also like say, function definition by cases. So there are several names. You can say like definition by cases. The D-E-F-I-N-A-T-I-O-N, definition by cases. See, by cases. C-E-S-T-S-S. So I'm just trying to give you some names. So it is piecewise-defined function, but you can like call it hybrid function, piecewise function, or definition by cases. And it's a very important stuff. It is a function that is defined by sub-function. You see this problem? This is a function, and these are sub-function with respect to that domain. So it applies to interval within the domain. So we'll be solving this problem, explain to you in the simplest form that you can understand, and follow up the Dolo YouTube channel. We believe that with our collective effort, we can transform you becoming a best mathematician. Stay connected and let's solve our problem. This is a piecewise-defined function. Like we said, you call it piecewise function, hybrid function, or definition by cases. So these are the two sub-functions. The question here says, evaluate the values of x sub 2. If x sub 2, these are the sub-function. The first sub-function says 3x plus 1 if x is less than positive 1. And the second sub-function says 4x minus 3 if x is greater than or equal to positive 2. So the major concept of this function is to look at the domain. What we are asked to find. We are going to, it is spelled out for x is less than minus 1, and for x is less than 1 and x is greater than or equal to positive 2, we are going to convert them because it's almost expressed in a set bill notation form. So we're going to interpret it. Then from the interpretation, we can like make it easier for you such that you will be able to capture the major concept. Because the goal of our YouTube channel is to present to you in a simpler form that you yourself can look at the problem, change the values, and use the same concept. Mathematics is about concept. It's not about memorizing problems, but it's about following the details. So in that slide, we say our solution. So we got if with x plus 1, 3x plus 1 if x is less than what? 1. So if we say if x is less than 1, it means that the values of x will be. So if we can say if we want to put in some notation f such that x is less than positive 1. This means that this will be s, the values of s will be all whole number that are less than what? Positive 1. We should start from the left side of the number line. Or we should start from let's say what? Like minus 2, minus 1, 0, equals this. These are values that are less than minus 1. That means it starts from the left side of the number line. That means you have a -5, -4, -3, -100 going down to the left side of the number line. So we interpret it. We're just trying to disassert beta notation, and we're trying to convert it in the simplest form that we can follow. Now, the second one says if we say x such that if x is greater than or equal to positive 2, that means x is greater than or equal to positive 2. To interpret this, we convert the sub beta notation and try to interpret it for you to better understand, because it may come in this form instead of this. So this will be our value here will be all numbers that are greater than that are less than or equal to positive, that are greater than or equal to positive 2. So this means that this is inclusive. Greater than or equal to, it means that positive 2 here will be part of the solution set, so it's inclusive. This is exclusive. It means that 1 will not be part of the solution set. That's how it starts from. We aim toward 0. So from 0 downward to the left side of the number line, the negative side, are numbers that are less than positive 1. So for s is greater than or equal to positive 2, we will now see that our values will be all whole numbers that are greater than or equal to 2. That means 2 will be part of the solution set. So we start with positive 2, positive 3, positive 4, positive 5, it goes to positive infinity. This one goes to negative infinity. So this is the major concept. How this means to us, it means that the second equation or the second sub-function of this piecewise-defined function give us the definition, because the domain we are about to form is within this function. Because if f is greater than or equal to positive 2, and we are asked to evaluate the values of x of positive 2, this means that 2 is part of the solution set. So we have already get this set up. So it means that we are using this second sub-function, because 4x minus 3, if x is greater than or equal to 2, it has the domain within the solution set. The domain f sub 2, this 2 here is the domain. Because in an order pairs, you often have in this parenthesis, in this order pair, there are 2, 3. This is the x value and the y value. And the x value is always the domain, and the y value is always the range. So our goal is to identify the domain that we are asked to evaluate within the function when they have been interpreted. So since we interpreted both functions in the first sub-function, we observe that 2, which is the domain that we are asked to evaluate, is not formed in the solution set after we converted it from a set beta notation to a solution to the solution we didn't find it. And then in our second sub-function, we identify 2 to be a part of the solution set. So we are going to use this notation. This is the function we're going to use. So say we're going to use this function 4x minus 2. So finally, on our solution, therefore 4x minus 3. So it means that f sub minus 2, let me erase it. So it means that f sub positive 2, will be equal to 4x minus 3. Why? Because the domain 2 is formed in this definition. So, however, you say must be equal to 4. You say the domain here is 2. We place the values of x with the domain 2. It's 2 minus 3. So it will be equal to 2 times positive 4 times positive 2 will give us positive 8 minus 3. So finally, 8 minus 3 will give us 5. So in this piecewise-defined function, it says we should evaluate the values of x of positive 2 if f sub f will be equal to the first sub-function 3x plus 1 if x is less than 1. If x is less than 1, we convert it to a set beta notation, and our values we got here, we didn't find this domain. Our major goal is to identify this domain when functions have been interpreted. Now, the second sub-function says 4x minus 3 if x is greater than or equal to 2. So since x is greater than or equal to 2, we interpreted the second function from a set builder notation to a simple set. We identify that 2, which is the domain we are given in our problem, is performed in the definition. Therefore, we just capture the second sub-function and then to solve our problem here. So in the second sub-function, we were able to solve, that is 4x minus 3. Everywhere we see x, we place in the values of x to be, that is by the domain 2. And finally, we have positive 5 to be our solution set for this piecewise-defined function. Like I said, piecewise-defined function is also called a piece function, piecewise function. It is also called hybrid function, and it is also called definition by cases, because it focuses on sub-functions with respect to domain, and the subdomain to see whether you can identify the domain you are asked to find or to interpret within each of the domains. So we are solving this problem. It's a kind of interesting problem. You can follow up the video, the methods, the steps that is being used in this presentation, or the steps that are being used, and you can create your own problems, solve. If you need help, you can email us, you can follow us, comment on our channel, just give us a comment. We can help you up in person, we can also help you up online to see how best you can solve this problem. It's very easy to understand. So thank you so much, guys, for following this presentation. We ask that you kindly subscribe to our YouTube channel, like and share our video, comment on our YouTube channel. Come on, subscribe now. We have a lot of great content coming up very soon, and we know that all of us, we can work together collectively to see how best we can take the word of mathematics to another positive thing. Stay safe and have a God bless us day. Thank you.
Hi guys, thank you very much for watching our video, and subscribe to our channel, the Dolo Tokpah YouTube channel. This channel was made to have you have easy access to mathematics. All of the math we solve, everything is very easy. You can understand it to your level, and if for any reason, we will appreciate that you share our video and comment, like that. Whenever we post new video, you will have it at your disposal. Thank you. I am the director, Benjamin George. Thank you very much for watching. Click on the notification button to have access to our video next time we upload it. Thank you very much.